So the unregistered Bandicam will only let me record 10 minutes. So I've already hit my 10-minute mark, but we got some more information to cover. So we're just going to continue on. So we were talking about computer A talking to computer B. When computer A needs to talk to computer B, it needs to know some information. It needs to know computer B's MAC address. So when it wants to send like a Word document to computer B, it needs to know where it's sending it, what network it's on, and various other components such as that. But the main key parts are the MAC address and the IP address. The MAC address is actually a unique value that is assigned to your network card. Each network card is going to have a unique one, and it's going to identify that computer specifically on the network. So when computer A says to computer B, I need to send you something, it has that MAC address. And it knows to travel down the line this way and go that way over to computer B. The IP address identifies the actual area network that the computer lives on. So if computer A needed to talk to computer H, it would also need the IP address of computer H so it knows to send that information through the router and into this local area network where its MAC address will route it to computer H. So I'll hide that for a second and I'll open up this packet information. So the base packet is going to have what are the data caps. This basically tells each packet is only 64 kilobytes in size. So no packet can be greater than 64 kilobytes, which is really small in today's standards. But each packet is going to have these caps on it, and it basically holds information like error checking and information about the packet for the session layer on when to open, when to close. And those types of things. It's going to link each packet together. It's going to have the basic structure information in there. As well as that, it's going to have the MAC address tied into the packet. And this is the MAC address for the actual computer. Now, it will also have its own personal MAC address for its computer. So computer A will also throw its MAC address into that frame as well, because usually computer B will want to talk back to computer A. So when it sends a packet over to computer B, it knows where to return a response. Again, same thing with the IP address, but this will go to the local area network. And then you have the rest of the space for data. Now, there's a couple other things included in the frame, but this is the basics and the basics elements of it. So this whole thing is known as a frame. So when the computer actually compiles the information, it'll break down your program or Word document, whatever you're sending, into 64 kilobyte chunks of these types of frames, and it'll send it out through the network. Now, how they used to do it in the olden days, probably not that old, but in the earlier days of networking, they would use these things called hubs. They didn't have the smart network switches, these things. So the hubs would actually have to request that MAC address. So it would send out a broadcast to the entire network. So computer A would say, hey, I'm trying to find this computer with this MAC address, and it would send that down all of these lines in the hubs. And computer B would go, oh, that's my MAC address, and send a response back to A, and then the packet would get combined, and it would send the rest of the information over to computer B now that it knew where it was supposed to be sending it to. Switches are a little bit more smart. When you actually plug a new computer into the switch, that computer reports its MAC address and IP address to the switch, and the switch will hold that into a table, so we don't have that extra latency of broadcasting. I'm sure it still happens, but computer A will be able to say, hey, I need this to go to this MAC address, and the switch will already know where to send that information because it has a table of which computers are linked to it and what ports that they are linked. And these little things on the back are called ports. So if this one was A and this one was B, you would route the data through that port. Let's see, packets. And that covers what happens when a packet is routed. Yeah. So now let me actually show you some of this is an office diagram that I had drawn up. So in a real life situation, this would be the network lines for that local area network. So they would run along the walls and to where all of the personnel are located. And each one of these personnel pieces would plug into a wall jack, which is these things right here, these wall jacks, which I'm sure you guys have seen on at your office. And so the main line connects directly into the server room and into the switch, and they all run into the wall for the workstations to be set up, and those are connected through patch lines. So if this computer wanted to talk to this computer over here, its signal would travel all the way through the line over here and into the server, and then it would get routed back out to whatever computer that it needed to go to. One thing I didn't cover is cable types and how fast speeds can travel. We've covered that a little bit in this class. So the main things that people are using now are Category 5 and Category 6 cables. They're leaning more towards Category 6 cables because they're faster. They are up to 1 gigabyte in data transfer speeds. There's also fiber optic cables, and the fiber optic cables are even faster, but they're going to be more expensive. So that is the basics of a computer network. In a brief nutshell, since I'm already almost 20 minutes over. So, yeah. All right. Thank you for listening. Hope you guys learned a little bit of something on networking. There's a whole lot more to cover. The lynda.com tutorials where I was actually studying these courses, there's probably 10 to 15 hours of information. So I really couldn't cover all of that, but there are a lot more components to all of these, and databases and file transfers and all of that. So it's definitely a very interesting topic, and if you are in the field of computer science, I definitely recommend that you look into it. All right, thank you everyone, and have a great day.